How are you, everybody who is watching this video? My name is Olenjolai&Nekinyi from beautiful country, Tanzania, eastern of the African continent. I'm very glad to be with you today, whether you are international or national viewer. As I said that I'm a Tanzanian, so that's why that I categorize some of you to be national or international viewer. I would like to welcome you into our online institution that's called the Online Undergraduate Polytechnic Institute of Tanzania, in square bracket OLENJOLAIM. Because I'm teaching mathematics, and even yourself, that I know that in your lifetime, if you're educated, you have studied mathematics, whether you like or you didn't like it. I would like to use the phenomenon, the terminology which is common in mathematics, we call it simultaneously. So simultaneously, I would like to welcome you into our YouTube channel that's called the Online Undergrad Polyinstitute of Tanzania, in square bracket OLENJOLAIM. Well, I would like to spend couples of the minutes just to remind you the vision that we have, so that you should be well focused. Probably this might be your first lecture, or this is just like when you have been moving around or maybe searching some of the contents online, and then instantly you met with mine. So I will be always reminding you of vision, because the word of God said that if there is no vision, people perish. So if I don't have vision on Online Undergraduate Polytechnic Institute of Tanzania, in square bracket OLENJOLAIM, then I'll be perish, and even this online program also is going to perish. So this is the vision that God has revealed. First of all, the source is my Father who is in heaven. and what he revealed to me, that he has given me an assignment to prepare, incubate, train, teach, mentor, and even leads some students who will be ready to take the classroom instruction in higher engineering mathematics, in higher scientific mathematics, also in the fundamental, just we call them core courses. For example, the core courses for electronics engineering, core courses for civil engineering, core courses in medical engineering, etc., 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 to combine with the knowledge of the Word of God found in the Bible in order to solve real-life problems. Possibly somebody is beginning to challenge whether that say that, you know, the Bible is for the Christians. I want to tell you, the Bible is not for the Christians. So when I say about the Bible, or the Bible, it doesn't. However, that Christians use frequently and often the Bible in everything they do, right? So don't have that conceptions that, so because that I'm not a Christian. No, I'm not convincing you to be a Christian. What I want to tell you, that there is a knowledge from the Word of God that you can combine with this classroom instruction. So listen. So it means that these few students will be ready to take the classroom instructions in those areas that I have mentioned earlier, combining with the knowledge from the Word of God, that the Bible, that also we have another department dedicated for that particular task, in order to solve real-life problems in the year community. Whether small-scale real-life problem, medium-scale real-life problem, or large-scale real-life problems. So regardless of the size, but our intention is to see at least every student during the continuations of the studies of undergraduate or after graduations solve at least a single problem in the year community where they are from, because that's the purpose of education. We are not going to college in order to get certificate. That's not the primary goal of education. The primary goal is in order to solve real life problems, and actually to improve the life of the mankind. Well, so that's the vision that we have. So in this online school, online institutions, we don't, our main objective is not to help students to pass exam. However, that will be helping them first of all to overcome the classroom pressure of failure. So if they'll be comfortable now that regardless of how exams will come, I'm going to pass, right? Then now I can take the mindset outside of the box, and that box is called the classroom, and I have to take them out of the box to focus to the real life problems, and then think every time, how can I use this knowledge to solve real life problems in my community? So that's the main point that I want to make before you. So our main goal in this platform is to see our students solving real life problems. from the small scale to the large scale, because what I believe it's possible. Even myself, when I'm teaching you right now, I'm solving my own problem that God has dedicated it for me. I have to solve before I go to the grave. Again, remember that if you're Tanzanian, that our country, it has been almost more than 6 years right now, when we have a mindset change. When I say mindset change, it means we have a mindset change that we want our country to be a country of industrializations. So when you talk about a country of industrializations, that they are a broad terminology. But remember that it's demanding educated people who will be ready to think on how solving our own problems and even our neighbors' countries' problems. So for myself, I will be participating in industrializations in different perspectives, but one of the perspectives on preparing the fresh mind of the Tanzanians and even some international who will be ready to take it and convey into the community in order to improve the economics of the country and economics of the personal or personal economics. So that's the vision. We have some specific objective. One of them is to help our students to pass the classroom with the continuous assessment. Again, we have another specific objective which is actual. We like to see all our students love higher engineering and scientific mathematics. So I have a lot of things to tell you. So let me just go into our today business. Stay tuned, focused, make sure to subscribe. In this channel, we're going to add more than 500 videos, and we have a focus, and you have to look to watch these videos sequentially. Don't jump around, because these are not entertainment videos. These are the learning and knowledge and even expensive contents that I'm going to provide. But this is my offering to my Father who is in heaven, who has given me a gift of teaching. Okay? So, we have some departments in this online undergraduate Polytechnic Institute of Tanzania, Olenjolai&Nekinyi. One of the departments is called the Higher Engineering and Scientific Mathematics, where we are right now. In this department, specifically, at this moment, I know that I'm going to teach 12 modules or 12 courses for the 4 semesters, for the 2 universities and 1 institution. Okay, so the course of the modules of the days is called Differential Question Complex Variables. This is chapter 2. This is the way that I categorize the concept, because I've been teaching this subject for almost 5 years before I record this. I've been teaching analog, it means physically, students who have been studying at the Dar es Salaam Institute of Technology. Okay, so the chapter, this I call ordinary and singular points. And this is lecture 4. So I've already taught you lecture 00, lecture 1, lecture 2, lecture 3, and this is lecture 4, which I want to teach about ordinary point of the differential question. Again, here there's this telephone number or mobile number. In case you feel from your heart, not outside, not from thinking, not being convinced by somebody else, from your heart, because this is the work of heart. I'm doing the work from my heart. I'm not forced by somebody. I didn't even be convinced by somebody. Okay, my alumni students who are more than 5,000 in a country of Tanzania, they're really encouraging me day after day. But it's something originating in my heart. So similarly to you, if you feel from your heart, okay, that you want to offer God, like myself, I'm offering God my daily offering, including this of teaching, because I'm offering my gift first of all, before my resources. Okay? And then if you feel from your heart that you want to offer God your free will in thanksgiving for what He has brought in your hands, He has brought in your iPhone, in your smartphone, in your iPad, in your computer, in your desktop computer, in your TV. So you may send your free will in thanksgiving in order to participate or to support the running cost, because it's very expensive to make those 500s of higher engineering and scientific mathematics to be in air for the present and future generation. So that's what I told you. We don't need just like we call it just allowances. No. So it means that everything you are going to offer it will be taken fearful and even revered with the fear of God to be used specifically for this ministry. Okay. So you can send your thanksgiving through this cell phone number 0759745331. And this module or this course, it has been studied in some of the universities in the first semester of second year or second semester of the first year. So regardless of which year, the issue is the contents. Again, in some of the institutions or universities or colleges, they don't call differential equations the complex variables. Possibly you may find that they call it engineering mathematics 2 or engineering mathematics 3 or advanced engineering mathematics. So regardless of the name, the issue is the contents. Because for example here that we are going to solve a differential equation is the power series method. So as long as you meet this power series method, it means that these contents are relevant for you, right? And mathematics is universal. So right now, I would like just to spend a few minutes on the doing quick review, okay, because now your mindset is ready. Quick review of previous lecture. So remember that we have already uploaded the lecture 00 in our channel, and also I advise you to watch these videos sequentially. Lecture 01, and then lecture 023, lecture 02, and also lecture 003. So let me do the quick review. This is all about the vision of what I've been explaining to you in almost in 8 to 10 minutes that of the beginning of this session. So if you watch this video, you get too much detail. It's almost a video of more than 50 minutes, if I'm not mistaken. So you get too much details. Again, there are some other institutions and whatever. So remember that the concept is in this in Tanzania, which is called the TZ, we have 2 accredited associations or association authorities which are supervising higher education. And this is TCU, and also we have the other ones which is called NATE. The long terms of NATE is National Council for Technical Education, and this is Tanzania Commission for University. So for NATE, here I say that I'll be using the Institute of Technology as a reference of all other higher institutions that are under category of NATE, right? However, that because there are the synonyms, there's a great synonyms, there's great similarities between the curriculums from one institution to another institutions which are focusing on competence-based, because NATE is competence-based and TCU focus on knowledge-based. Okay. So I know for those students, for higher engineering students have understood what I'm saying. So just to do the quick review of this lecture 3, mainly we were focusing, first of all, we remember about previous ordinary differential equation, whose we say that coefficients are constants. So coefficients are constant number, okay, constants, right? So you have, that's what we review. So for example, we have 4y double dash plus 4y single dash minus 4y or minus, let's say, 6y. Okay, this is equal to 0. So this is an ordinary differential equation whose coefficients are constant numbers. So you said we had so many, we learned almost, for example, myself, I know how I can solve this format of the questions by using almost right now 9 to 10 methods of solving this differential equation of this format. So we said again that the challenge, the real life problem, the real life engineering problem, real life engineering and scientific problem, right? So they don't give this type of ordinary differential equation. Most of them, they give ordinary differential equations which their coefficient are what? Are functions. It can be polynomial function, but it's common for the polynomial function, p of x, and then we say that q of x, y, single dash, and then we say, let's say, plus what? r of x, y is equal to 0. And this is give if and only if p of x is not equal to 0. So this is the type of the ordinary differential equation we are dealing with. It's the second order, like this one. This is the second order ordinary differential equation. This also is the second order ordinary differential equation, but the difference is the coefficients. So the coefficients at the point that we have differences. So because of this difference of coefficient, even the way of solving it will be different, because here we used to have some complementary and particular solution, but in this case we are going to have something called the power series solution, right? Power series solution. So our solutions will be in series. That's why that I taught you in chapter 1 about series and sigma notation. Okay? So you have to remember and learn this stuff or this contents sequentially and with a great care and with a great love, because we are not confusing you, but we want to help you. So before we go into the contents of ordinary point or differential question, where we are going to touch a little bit about lecture array, I want just to give you a conceptual question, okay? And this will be example 7, right? Example 7, and this is concept, okay? And this question is one of the past paper, because I told you that questions and answers reference books. Some of the, you have to make sure that you should go through the past papers of the previous year to see how questions have been asked. Okay, so concept. So we say that let me share with you the reference. The reference is the final exam, which abbreviations we call the FE of 2016, right? With a DAT, so it is DAT final exam. Okay, as I said, that I'll be using the reference. Okay, refer DAT final exam of 2016, first city, not supplementary. And then just if you have that paper, go to the section A, question 1F. Okay, question 1F, definitely. Just question 1F. Okay, so let me show you. Let me bring the lens so you might trust what I'm telling you. Because I know some of the students, they always not trusting. So this is the past paper, right? So this is the past paper, the rest of Ministry of Technology, that's of General Studies, semester 1 end paper examination, right? So, okay, so we say that in this differential question, complex variables. This is February 2016, and then this is a question, okay, and these are the other questions, etc., etc., etc. So let me write the questions and then solve it. Because for those students for international, against our dear students who are international students, don't get discouraged, don't get disappointed because I'm mentioning Tanzania or the essence of technology frequently. Just to feel happy, because even if you watch some videos of Stanford, they used to mention about their curriculums, because that will make something should have paid a focus, okay, rather than doing something general, because you know that every institutions, every country, they have their own educational system. So just to feel happy, I will cover the contents that you need. I know that even yourself, you know what are the course outline, because that's very important for your course. So check your course outlines, because I've listed the contents and the topics in my course outlines, so you can check and then you can say, yeah, so this is I have to learn from Sir Olenjolai this concept, because I believe that it will make me to understand. Because even these examples and all of these questions in this paper, they've been taken from the universal books. You can find them in India. For example, advanced engineering mathematics by Scout. So they are well used, well. Okay, so the question asks you that, write as simple. So I wrote concept, it means that you have to be careful when you be solving this problem. Single series, there's a concept there which has been hidden in this question. That's why that I said I'll be happy to hear, or I'll be happy to see my students also discover the concepts or the trap, right? The trap in this question before they go into the year continuous, into the year testing, or into the year next final exam. So we have x plus 2 square, then you have sigma notation. This is what? N is equal to 3. Okay. However, that because of the printing or of the typing, they wrote n is equal to 3, right? And here I wrote what if you want the answer of this one? I told you that first counting index, last counting index. This is the kind of coefficient. And then here we have n, a. This is the subscript. Okay, summation index. Here you have x plus what? X plus 2, n minus 4. Okay. So then we say minus. So you see, this is summation coefficient summation index, subscript summation index, superscript summation index. So this series has 2 terms. Second term is this. So you say that n is equal to 1. I would like us to copy the way it has been typed, so that in case you find again another question in this format, don't raise up your hands and ask you for correction, okay, or ask you for a question, because your teacher or the invigilator will never help you, because it's something known for the mathematicians. 3 marks. So if you do the questions, you'll have 3 marks in exam. Okay, so solution. Okay, so when we analyze this question, we have how many terms? 2 terms. First term, second term. So you have to understand, write as single series in terms of x plus 2 square the following series. So this is not a single series. This is a double series. That's number 1. That's the first thing that you have to remember. This is a double series. So let's say the first step, say that it is what? Double series. Why it is double series? Because it has what? 2 terms. So single series, so for that sentence, single series, say single series. Single series has only 1 term. Has only 1 term by the means of the single series. First of all, you have to understand what you have been asking to do. Well, so if that's the case now, if this is a double series or 2-term series, then we want to get the single series. But again, we'll be given some other condition. So number 1, we'll be asked to write it as a single series, right? A single, okay, single series. Write as, this R is not there, but it is here. Write as a single series in terms of this one. So there's the second condition. The first condition is single series. I have already explained. The single series has only 1 term. When you say that 1 term, we have only 1 sigma notation in the series. When you say that it's 3 or triple series, it means that there are 3 terms. Okay? So the second condition, it means that in terms of 40, x plus 2 square, this term has to arise. When we examine, okay, we have in this term already. So we have x plus 2 square. Don't worry about the summation index. But in this term, we don't have it. So the technique is we have to make sure that we arise x plus 2 power 2 here. That's the first business that we have to do as engineering and the scientific mathematician. And the second business again, in order for us to have a single sigma notations, to take the sigma notations out of the bracket, then their first counting index or the first counting index of these 2 terms should be the same. So if it's quite different or it's different, we have a business of using the principles I told you in lecture 2 of rising and lowering or we call it shifting or folding of the index. Right? If you have any question, don't hesitate to ask in the comment section. Okay, so let us go to the second step. So second step, we say that consider, because the first term is okay, it's already in the second condition. Consider the second term. Consider the second term of the series. Where the second term? This is the second term. This is the second term. And this is the first term. Okay? So second term of what of the series. So what is it? So let us write here. So we have n. So we can just use our normal way of writing the counting index to infinity. And then we have what? We have n, and then we have what? We have x plus 40 plus 2 power what? Power n plus 1. Right? So if that's the case, we say, okay, so after we consider, we say that our main objective, we want to get x plus 2 power 2 outside of the sigma notation because it does not contain the m. So we say that, let's say simplify, right? So to simplify, what we say? We say that, okay, fine. So we have n is equal to 1 to infinity. Then we have n, we have an, then you have x plus 2, right? And then we say that power n by using the law of indices multiplied by x plus 2 power 1. Right? Power 1. So after having these simplifications again by using the law of common exponential, then we say that, okay, fine. What do we need in order to have x plus 2 square? It means that we have we should make sure that we have again the multiple of x plus 2 power 1. How can we achieve that one? It means that in the process of series, or in the principle of series, we have to raise the summation index by 1 in order to have n plus 2. So n plus 2, it will be x plus 2 power n plus times x plus 2 power 2. So we have to raise the summation index by 1 and we lower the count index by 1. Right? So that's the steady state. Because we should know where we head. We have already been conditioned, so we know our destination. So we say that we raise the summation raise the summation index by 1 and the lower counting index. So you see now the applications of the concept I taught you in lecture 2. Lower the counting index by 1. So how do we do that? So we have our second term yet. We are dealing with our second term. If we lower, we subtract. Okay. Then this is the coefficient summation index. We raised it by 1. And then this is the subscript summation index. We raised it by 1. And then here we have what? X plus 2, right? And then we have, let's say, n plus 1 plus 2 plus 1, right? So this will make it n plus 2, which if we simplify in this format, now we've already got our expression. Okay. Tell me you're enjoying this beauty of higher engineering and scientific mathematics from which institution, from which college, from which university, from which continent, from which country, right? If you're in Tanzania, from which region? Tell me that in which city that you enjoy this stuff. So then, if I keep on simplifying, because our main objective here is to take a complex concept in engineering mathematics and make them simpler and simpler in such a way that every engineering student can bear it. Okay, x plus 40 plus 2, then we have power n multiplied by x plus 2, then we have power 2. So then now we can take this out of the bracket. So if we take out of the bracket, now we have x plus 2 as the second condition, then you have sigma notation, n is equal to 0 to infinity, n plus 1, and then a n plus 1, and then x plus 2 power n. So the condition is dealing with this, it's a term which does not have n, right? So it's not just like in the nth term. Okay. So if this is the case now, if we restore these expressions into this place, so we go for the first system. So first system, we say that you write the series. So if you write the series right now, we start with the first system, which is x plus 2 square, and then we have the sigma notation, n is equal to what there, to 3, and then to infinity. And then we say that n a subscript of n, and then we have what you have x plus 2 power n minus 4, power n minus 4, power n minus 4. Then we subtract this with the new term right now, which is x plus 2 square. Then you have sigma notation, n is equal to 0 to infinity. Then the coefficient is n plus 1. Then we say that an plus 1, we'll have x plus 2 power n. So our second point of focus is already achieved. But what are we looking for? This is the double series, or a series of 2 terms. First term, second term. So how can we simplify? So the next step now, we have to think, we have to check. Because expressed just as the single terms is mean that you have a single sigma notation. In this first term, the first count index is n is equal to 3. In this one, the first count index is n is equal to 0. So these two counting indexes are not the same. So we cannot make this sigma notation common in this state. We have to think again, to rethink, and to use the concept that I've taught you in the previous lecture as engineering students or certificate students, and you have to think, how can you make them the same? And this is the very important business, because in power series, Whether we'll be using the existence, we're solving problems by using the existence theorem or by using the Frobenius theorem, we'll be doing this business frequently. In almost that in more than 80% of the problems, we need to think, how can you make the first counting index of the same series of with the different terms, maybe 5 terms or 4 terms or 3 terms, to have the same the same value, right? So you have to think. So because here we have n is equal to 3 and n is equal to 0, between 3 and 0, which is the smallest number, 0, right? So according to the principles of ordinary differential equation, we have to lower this first counting index to 0. So our destination, we have to make sure that this one comes to 0. So the large counting index should be lowered to the smallest counting index. So now we go back to the lecture 2, where I talked about index or shifting of the index. So how can we make this equal to 0? So n is equal to 0. In order to make this to be equal to 0, we have to lower the first counting index by what? 3. Okay? And then if you lower by 3, we have to raise the summation index. Each summation index, how many summation index we have here? 3. 1, 2, 3. We have to raise it by what? By 3. And then afterwards, now we can take the sigma notation outside of the bracket. And you will see this concept, I promise you, later on when we'll be solving about power series solutions, especially when now we want to get a recurrence formula. So if we have to get a recurrent formula, it means that we take all the terms, because now we find we have the single sigma notation for the 3 terms or 4 terms. So we take it out of the bracket, and then we have something we call the identity property. And let me show you. Okay? So now we say that the next stage, which is the fifth stage, we say that let us raise the counting index. So let me write. I'm writing this stage for you to review them easy. The counting index of what? Counting index of first term. Okay. Counting index lower, not raise. We have to lower the counting index of the first term by what? By 3. And then oh, mathematics is beautiful. Okay, and then raise what? Raise the summation index. Raise the summation index by 3. So let us do, okay, by 3. So let us do this fantastic business. We have x plus 2 square. Then this is the sigma notation for the first term, where we have n is equal to 3. We lower this 3 by 3. And then here we have infinity. Remember that I told you also here we can reduce by 3, but infinity minus 3 is equal to infinity. And then here we have to raise the coefficient summation index by 3. Also, we have to raise the subscript summation index by 3. And also, we have to raise the superscript summation index, which is x plus 2 power to n minus 2 by what? By 3. Then we have minus x plus 2. And hence we have our summation index. And here we have n is equal to what? N is equal to 0 to infinity. Right? To infinity. And then here we have what? N plus 1. And we have what? We have n plus 1. Okay? N plus 1. And then we have what? We have x plus what? X plus 2 power n. Right? We don't do anything else in this second term. So if we do the simple algebraic simplification, x plus 2 square, this is equal to what? Okay? The counting index is n is equal to 0. And then there the last counting index is infinite. Then you have n plus 3. And then you have n plus 3. Then you have x plus 2. There we have what? N minus what? Plus 1. Okay? N plus 1. n plus 1, n plus 1, and then we say that minus what? So minus, excuse me, I made a mistake. This n minus 4. That's what I was thinking around. What's coming or what's going on? It's n minus 4. So negative 4 plus 3, this will make n minus 1. So not plus 1, because I was thinking no plus 1 means this will be x plus 2 power 3. So I think that you understood why I was shocked. And this also I forgot, it is squared. Okay. Thank you, God, for reminding me and correcting me, because I'm a human being. Okay, n plus 2 square, and then this guy is what? N is equal to 0 to infinity, and here we have n plus 1, right? And then this is a n plus what? 1, so x plus 2 or n. So you see, okay, this is a kind of the simplified term or series, but it's still double series. What we have in common, the sigma notation, the counting index is the same for the two terms, and the summation index and the counting index are the same, but these other terms are different, so don't worry. So what are we going to say? So we go for the last step, which is the sixth step. So the sixth step, we say that simplify what? Simplify the double series, okay, into single series as required by the question. Okay? Remember that Olenjolai does not know everything concerning about differential question or concerning about high engineering and scientific mathematics. I just know a small portion of what I'm teaching you, but I have a responsibility from heaven, not from the earth, from heaven, that I have to teach you, everybody who wants to learn what I know. So I'm doing my business. So to simplify, we say that we have x plus 2 square, and then we have summation, and then here we have what? N is equal to 0 to infinity, okay, to infinity. And now, okay, so we took this as the common terms. We can even open a square bracket like this. Then the next term, we start with this first term, the summation index of the first term. So you have n plus 1, and then you have a n plus 1, we have x again, power what? X plus 2 power n, x plus 2 power n, then we have minus, right? Where that minus? Oh, excuse me, I took for this, okay, excuse me. I took the terms for the second term, okay? So, however, that is it's the same, but I don't want to confuse you. Where is our first term? This one. So the summation, the coefficient summation index is n plus 3, and then you have a n plus what? Plus 3, okay? A n plus 3, and then here we have x plus 2 power n minus 1, right? Minus 1, and then you have a big minus. For this second term, we have what? n plus 1, and a n plus 1, right? Plus 1, and then here we have what? X plus 2 power n. And then we close the bracket. This now is a single series. Single series with the n stem. This is n stem, first the counting index, last the counting index. This is the kind of the coefficient term. Okay, this is the coefficient summation index. This is the first counting index. This is the summation counting index. These are the terms or the variables of the series. Then that's the, so there it means that you have your 3 marks. At the end, you're solving that problem. Okay, so let us go to the interesting topic. Let me introduce to you this second topic. Okay, introduce to you this second topic after covering part of the series and so forth. So this second topic, we say that ordinary point of differential question. So let me take now. Let me teach you a new concept. Remember again that some of the classes comprises students. Okay, ordinary ordinary point. Some of the classes means that include students from ordinary diploma and the others from advanced secondary school, right? So what happens according to my research? Differential question, right? What happens according to my research? These students who are doing undergraduate studies, but they are from ordinary diploma, they are confident on the core subject and they know more than these who are come from advanced level. However, that the students from advanced level in some of the institutions, for example, at the Institute of Technology, they spending 1 year to compensate what they didn't compensate in advanced education because they are learning now engineering. They are no more learning about advanced science. However, that I have my official channel to teach them also. So, and also these students who are from advanced education, they are well believed that they are competent in mathematics. And even sometimes, I remember that some of the students, especially these ordinary diploma students, they believe that these students from advanced education, they covered everything about higher engineering and scientific mathematics. That is completely wrong. I'm a product from advanced secondary education in Tanzania. So what I'm teaching you, we have never touched it even in advanced mathematics. I know the contents of advanced mathematics Form 5 and Form 6, and I teach in my online school that called Tanzania Online Advanced Secondary School in square bracket OLENJOLAIM. And I know the content for the basic applied mathematics for those who didn't study advanced mathematics during their advanced education. So I know the contents. So I know what I'm telling you. So these contents are new. Whether even if you're a student from advanced education, sometimes you cannot concentrate. I know this stuff. Well, I know that maybe possibly you know about integrations and whatever. But the issue, the concept of ordinary point, we learned about ordinary differential question, but we didn't learn about ordinary differential questions which have a coefficient of the function. We didn't have anything else about ordinary point, about singular point. We learned about sig, but you haven't heard anything about index, shifting the index. We have never heard about that one. So that's my message for advanced students. For me, I took them with Hannah. I was patiently, I was respectfully, and I was open in my mind. Okay, let us continue. So we have ordinary point of differential question, because if you say you are writing the subconscious mind, even if you sleep, you say that possibly I might call my festival ordinary point. Say ordinary point of differential equation. So we say that the standard, let me start it from this word. The standard ordinary second order differential equation with what? With constant variables, or with function of the dependent variables. We call it with required at the constant coefficient, variable coefficient. With variable, when you say variable, we mean function coefficient, right? Function coefficient. Okay, function coefficient. Function what? So it's a variable or function coefficients. Okay, is given as this p of x. Okay, and hence we say that this is coefficient of the second order plus q of x, and then this one we write as dy dx plus r of x y is equal to 0. Okay, is equal to 0. Again, this we can write as p of x, and then we have what y double dash plus what q of x, then we have y single dash plus r of x, y is equal to 0. So this is the standard ordinary differential equation which we are going to use from now until the end of this main subject of power series solutions of ordinary differential equation. So we'll be recording that equation often. That's why I wrote it. But remember that the condition is this: if P of X is not equal to 0. That's the condition. So we say that we can give this equation forcibly that the number that P of X y double dash, remember that, plus what? Q of X y single dash, then R X y is equal to 0. This you can call it equation 1. Remember that also y double dash, this is the notation for the second order differential equation, just to remind you. And y single dash, this is the notation for dy dx. So y is equal to y. So you have to understand. We'll be writing, because of the space and time, we'll be writing possibly by using this format. Okay. So if that's the case, we say that if a 20, we say that if, so remember that P of X for this case, and Q of X, and the R of X for this case, R of X are functions. If you remember in the lecture, they are functions of 40, are functions, okay, are functions of independent variable, function of independent variable. And we limit this one, we say that the function for, we say that if for power series solution of this level, we say that the functions, let's say the functions, so we say that the functions, okay, are functions of independent variables. Okay? So we say for power series solution, the functions coefficient, the function coefficients are polynomial function. However, that in case of the finding the ordinary or singular point, you might find trigonometrical function, exponential function, so you can find even some other hyperbolic function, you can find those. But that's for the purpose of only finding the ordinary point and singular point. But if we'll be solving now a differential equation, the method we'll be using the two theorems, that existence theorems and the Frobenius, is limited for the function, for the coefficient functions to be what? Polynomial. Okay, should be what? Polynomial function. So that's very important point. Okay, so we say that now. So according to the mathematicians, especially the earliest mathematicians, we say that if the solution, if we solve this differential equation by introducing that maybe x at the point, it means that this is a function. For instance, if for example, if you say that P of x, it is x plus 1. So if x plus 1, it means the value of x will be ranging from what? From negative value to 0 and to positive infinity. From negative infinity to 0. From negative, it means that for your side, it means from negative infinity to 0 to positive infinity. Those are the values. So one of the values here is 0. So when you say about ordinary point, we are talking about this finding the point where x is equal to 0. That means of ordinary point. So he said that what is, let me go to the fundamental question. What is ordinary point? What is ordinary point? What is ordinary point of ordinary differential equation? This is the abbreviation. So he said that given, this is the answer, right? The solution for the question. Given P of x y double dash plus Q of x y single dash plus R of x y is equal to 0, right? So then we say that then if, okay, say that if if a point, yes, that's what I forgot, if a point x is equal to x naught, and this is equal to 0, right? If a point x is equal to x naught, exist, right? If a point x is equal to such that, exist, such that p of x at the condition p of x is equal to x naught is equal to 0, should not be equal to 0. Then the point x at point x is equal to x naught is equal to 0 is an ordinary point. So that's how we define in mathematics sum. So here's the definition of the ordinary. So what the ordinary point? We have been given a standard ordinary differential question. Remember that this one I called it standard ordinary, as a standard second order ordinary differential equation, right? So it means that if a point x is equal to x naught is equal to 0, a certain point within this function, right, exists, because it can exist or it cannot exist, such that p of x is equal to x naught is equal to 0 is not equal to 0. It means that if I take now a point where x is equal to 0, I substitute into the differential equation which contains the coefficient function, and we find that the coefficient function p of x, after substituting its polynomial functions by 0 or with 0, the result is not equal to 0. Then we say that that ordinary differential equation possesses ordinary point. Let me repeat. I know it's a kind of the confusion. Listen. For example, however, that we do examples. If I have x minus 2, then y double dash. And then I have, let's say, x, y single dash. And then plus y is equal to 0. Let me explain by using the simple example like that. So this is an ordinary differential equation which have what you call the variable coefficient, or which have functions as their coefficient. So the function is x minus 2, function is x, and here we have a constant term, right? So what do we say? So having this point means x there, it can take value from negative infinity if we don't limit to 0, and then from 0 to positive infinity. So one of the point here is 0. If now we say that we are looking for that point where x is equal to 0, and then so we take x is equal to 0, we substitute, and we'll be dealing only with this point because this is the point that we have to limit for us to be valid. If we substitute x is equal to 0 here, then 0 minus 2 is equal to what? Negative 2. So now we come to this condition. It means that if a point x is equal to x naught is equal to 0, is that a certain point, we substitute it here, we get negative 2. Then, is negative 2 equal to 0? No, it's not equal to 0. So, because it's not equal to 0, then x is equal to 0 for this differential equation is ordinary point. Interesting. Tell me in the comment section if you've understood. I'm trying my level best. I pray to God to give me a very simple language for any student who at any level, whether slow learner, whether faster learner, whether intermediate learner, to understand what I'm teaching. And I'm telling you that this is my 6th year of teaching differential equation comparative variable, but I want to teach it in a different way, in a very simplified way, very interesting way, and even in a kind of the entertainment way, because mathematics is a song, right? So that's the one point that we have to remember. So point x is said to be ordinary point of the differential equation. Okay, so that's the condition. So then the neighborhoods of the XDR equations can be written in this form. Okay. So again, if that's the case, now you have understood, I can give you some descriptions before we go to the examples. They're not too difficult. But again, you have to understand how we are finding the ordinary point, because this is the entrance. It's another concept, the second concept that we are going to use on solving ordinary differential equation by using power series method. So if you understand this, you're in a good position, my dear students, I want to tell you. So he said that then in the neighborhoods of the x is equal to this one equation can be, so he said the neighborhood point, the neighborhood, so they say neighborhood It's just like the word of God said that love your neighbor in the neighborhood as how you love on yourself. I have to love my neighbor like you. I love you so much. You are my neighbor. I love you as how I love myself. Why? What I'm teaching you is what I struggled myself even before taking the classroom instructions when I was doing my undergraduate. So I struggled myself. I was going through myself in advance before the teacher came to the class, and I understood, and even that it simplifies my life. And I was also teaching my classmates these modules of differential question copies before doing the test 1, test 2, before doing the final exam. I'm not saying that because I want to boast myself. Always, I'm a humbled man, right? I'm a humbled man. I'm a respective man. I'm a disciplined man. But I want to tell you, in order for you to understand the grace of God upon me on teaching. Because for all the glory and the praise of this business that I'm doing should go to my Father who is in heaven, who lives forever and ever. Okay, so the neighborhood points. Neighborhood points of what? Neighborhood points of xc is equal to x naught, or sometimes we simplify. Just the mathematics, you write x is equal to x naught, we understand that this is the origin. But also simplify, because you know that not everybody who have a mindset of mathematics every time. Okay, the neighborhood points of x is equal to that ones, right? Can be written now. So can of equation 1 above can be written in the form of what does it mean? We have our standard ordinary differential equation p of x double dash plus what? Plus q of x single dash, and then plus what? R of x y is equal to 0. So we can divide this term with p of x, and we can divide this term with p of x. We can divide this term with p of x. So if we divide, we say we have y double dash plus what? Plus q of x over p of x, right? And then so y single dash plus what? R of x over p of x y is equal to 0. This again very important point, because I have written this equation in form of what? In form of the standard equation, and we'll use that equation in solving or in finding the singular point, in the special also class, find the singular point. Remember to have the reference book, and you have your scientific calculator. If you don't have your scientific calculator, read the descriptions below, and then you'll see that how you can order it and we can sell it to you in any regions of Tanzania, right? So there is a condition for what? Condition for ordinary point. Condition for ordinary point to exist. So there are two conditions for the ordinary point to exist, of ordinary differential equation to exist. The first one is this. We say that the point x is equal to x naught is called the ordinary. This is called the ordinary point of standard equation 1 if both rational coefficient or fractional coefficient, both coefficient means that p of x, not q, not p of x, q of x over p of x, and the second coefficient, which is r of x, right, over p of x of what? Of equation 2. This is equation 2. These are both analytic. Okay? In the standard form of the R, analytic. So I will teach you later the means of analytic. But right now, just keep in your mind that the condition, this fractional function and this fractional function, because we call it fractional function, or rational function, most of them they should be analytic in order to have that ordinary point. Okay? Analytic where? Analytic at x is equal to x naught is equal to 0. Okay? Is equal to 0. So the second point, again, the second solution, second point is not necessary action. Say that in the neighborhood, we consider the solutions of this one in the neighborhood of its ordinary point. So number 2, we said that the solution means that we say that in, let's say the point x is equal to x naught is equal to 0 should involve, or we say that should involve the neighborhood points. This is just the literal concept. Okay. So if the case now, if you have any question, don't hesitate to ask in the comment section. I'll try my level to answer your question. So my lectures will be not more than 2 hours. Okay? You have to understand, to be within an hour and 2 hours. So in between there. So let us now go to the problem solving. The point where many students like, because we've been speaking and we'll be using letters. Now let us see how questions are asked. So we are done with example 7. Now I'm going to do example 8. Okay? Example 8, simply, this is the way. And these are in the final exam or the university exam, okay, or any exam, right? End of a semester exam, you find that these questions appear in section L. But for the test exam, you can find that these questions appear in the first questions of the test paper of that test. Find all ordinary points. Find all ordinary points. If it is 1, all ordinary points of the differential equation. The differential question below. Okay. And this is what? X minus 4, then second derivative, okay, then plus what? Plus a real, x minus 2, we have dy dx plus 5y is equal to 0. Okay, so the question asks us to find out all ordinary points. Why is it plural? Because sometimes some of the questions they might have more than one ordinary point. So don't worry, more than one singular point. So don't get confused. Find what is there. Okay, and there's no need for you to claim that what the type of the question that you have 2 ordinary points or 3 ordinary points. It's not necessary. Solution. Okay, and if I'll be solving this question by following steps because I want all my students to understand them once and then wait for the question, okay? And then think it, where are we going to apply in our real life? Okay, so he said that the first stage of solving this problem, we say that compare the given ordinary or second order, because this is the second order, ordinary differential equation with what? With the standard second order ordinary differential equation. Okay, a differential equation. How does it state? P of x second derivative plus q of x first derivative dy dx plus r of x y is equal to 0. So if we compare, we find that the function p of x is equal to what? X squared minus 4. Again, if we have compare again, we find cube of x is equal to 3, then x minus 2. And if you compare again, r of x is equal to a constant function which is 5. Afterwards, the next step, we have to state the condition that the ordinary differential equation has to obey in order to get to the ordinary point. So the second step say that for ordinary point to exist, ordinary point of the second order differential equation to exist, we say that then we say that for the ordinary point, and this ordinary point equality at x is equal to x naught is equal to 0 of second order ordinary differential equation to exist. Then we say that then p of x is equal to x naught is equal to 0. It should not be equal to 0. That's the condition. So you have to test it and solve every question by this condition. So that's the second step. We go for the same step. How can we use the condition to solve that problem? We say that from we'll be given p of x for our question is equal to what? Is equal to x minus 4. Is it x squared? X squared minus 4. So we say that substitute x is equal to x naught is equal to what? Is equal to 0 in what? In the function of p of x first. So we say that p of x is equal to x naught is equal to 0. This is equal to what? In position of x we introduce 0 minus 4. 0 squared, 0. 0 minus 4, the answer is equal to negative 4. Then we have to ask ourselves the question. Okay? We say that is negative 4 equal to 0? No. So it means that negative 4 is not equal to 0. Right? So the condition we say that ordinary point will exist if p of x is equal to x naught is equal to x naught is equal to 0 is not equal to 0. And negative 4 is not equal to 0. So because p of x is equal to x naught is equal to 0, is not equal to 0, is equal to negative 4, then the ordinary point exists. So therefore, we say that, therefore, x is equal to x0 is equal to 0 is an ordinary point. Then you are done. So in some of the differential questions, you find that if you follow this procedure, and you find that at the end of the day, the p of x is equal to 0, which makes it what? Non-ordinary point. But what will it be? It will be singular point. So that's let us go to example 9. Tell your neighbor we are in example 9 of differential question. Example 9. And tell me in the comment section, you enjoy this session or you don't? So the question again asks you that find ordinary point. Find the ordinary point ordinary point of the given ordinary differential question below. So this is x y double dash plus sine of x y single dash. So you see that this is a trigonometrical function. Then here we have x squared, y is equal to 0. So if you analyze this question, this is the polynomial function. Again, for this case, this is the polynomial function. This is the polynomial function because it is x, it is 5x power 0, and the variable power 0 is 1. This is polynomial function, this is 3D function, this is a polynomial function. I told you, when we'll be finding the ordinary point and singular point in general, not at the part of the power series solution, then we'll be considering any coefficient function, right? Any coefficient function. So to do that, what do we say that? Say that you have to solve it. Don't worry about that. Just follow the 3 steps that I told you. First step, I told you what? Compare a given equation. Compare a given ordinary differential equation with what? With the standard. It's the standard what? Equation. What is the standard equation? It is P of x, y double dash plus q of x, y plus r of x, y is equal to 0. So if we do compare there, if I find P of x is equal to x, you can pause the video and try to solve this question yourself and check whether the ordinary point exists or not. So you're allowed. So you can pause the video, do on your own, on your hands, because I want serious students, and that's the way that you master mathematics on doing yourself. You do it, and then you play the video, right, continuously, and let it continue, so you can see the solution, because myself I'll be solving there, so you can see where you have missed out outside of the exam, and you correct yourself. That's what called the practice makes better. So P of x is equal to x, and then Q of x is equal to what? Sine of x, and then R of x is equal to x squared. Right? So this is the truth that we have. Wow. So we are in this point. We have to recall the secondary step. In that function, we don't need every part. We just need only one part. We say that we can write even the question this one. If P of x is equal to x naught is equal to 0. Some of the books and some of the teachers, they used to write this condition this way, right? It's not equal to 0, right? It's not equal to 0. Then x is equal to x naught is equal to 0. Is equal to 0 is, so this one is what? Ordinary point. This is the ordinary point. That's the condition. So here we go. So that's the second step. And go for the third step. The third step now is substitute the condition. Okay, so from what you said that is from P of x, which is equal to x, we say that we have to substitute what? We have to substitute x is equal to x naught is equal to 0 in what? In P of x. Okay, so let us see this is going to happen. I think you have seen something when you've been doing practice yourself, that this is a little bit different concept. So now we have the P of x, remember, P of x, according to the given equation, is equal to x. So now we want to substitute P of x is equal to x naught is equal to 0, and this is equal to, in x we put x to 0. So P of x is equal to x naught is equal to 0. We say that, okay, excuse me here. Let me do the minor correction here. I made a mistake, excuse me. This is equal to 0, is not equal to 0. Then, yes, so this is the condition. I see somebody is shaking the head. Yeah, right now, sir, you are right. Yeah, I do mistake. I'm a human being. Okay? I'm human, but I'm learning, so the mistake that I do. Okay, so you find that now the conditions mean that the P of x is equal to x naught is equal to 0 should not be equal to 0. for the point to be what? Ordinary point. Now, after finding, we find that P of x is equal to 0 is equal to 0 is equal to 0. Then this differential equation is already the condition for it to be what? To be ordinary point. So we say that, for that case, you say that x, y, double dash, so plus what? Plus sine of x, okay, sine of x, y, single dash, plus what? Plus x square, y is equal to 0. Disobeyed. Disobeyed what? Yeah. Disobeyed the condition of ordinary point. Condition of ordinary point. So if that the case now, what do we say? This is what you have to know before you conclude. If the point, if x is equal to x naught is equal to 0, is not, the write in capital, in system, is not an ordinary point. An ordinary point, right? It's not an ordinary point. Then, it's not an ordinary point. Then, it is singular, singularity, singular point. So this is just for the matter of understanding. However, that in lecture 5, I will teach about singular point and how you can find it of the ordinary differential equation. But now, how can you conclude this question, right? So you have to say that therefore, because the question asks you to find ordinary point. You just say that x is equal to x naught is equal to 0 is not ordinary what? It's not ordinary point. That's all. It's not ordinary what? Ordinary point. That's all that you want to say. You can say even if that, okay, so it's a singular point. That's all. Is mathematics, is it high engineering, is high engineering mathematics and high engineering scientific interesting? Yeah, you just enjoy. It's just like you're singing a certain song, and if you reach the ordinary point, then you have a chorus. And hence again, you go to the festivals of engineering mathematics, then you come back to the chorus, and then you go to the intro, then you come back to the chorus. You go just the turn of the song, you come back to the chorus. And then you go against to the bridge of the song, you come up to the chorus. And then you go to the tax of the song, you come up there. Because, you know, one of the applications of mathematics is in music. I love so much praise and worship music. And I'm a student, I'm a musician's student, so I understand what I'm telling you. And I see real mathematics in music more than I think. Okay, so let me do the last example, then give you the homework, because time is over now, and I know that you are already exhausted. So let me do the 10 examples, and the 11th example, I will give it to you. So this is it, example 10, yeah, okay. So this example 10, let me just solve something else. Okay, so it's just the same, but we have another differential equation. Find the ordinary point. We are trying to change and show you different possibilities of solving differential equation for ordinary point of the ordinary differential equation in life. So for this one, it is x minus 5. I just mentioned about the sum, and then now you hear it. Okay? So it's interesting. Y is x squared, and then this is plus cos of x. Okay, then this is dy dx. Okay, plus what? Sine of x, y is equal to 0. Yeah. So when I'm trying to lower the voice of that music, then pause the video, solve that problem, and then I will be solving it if you are trying to solve it. So I believe that now you are done with your solution. Okay, I believe that now you are done with your solution and you are ready to enjoy the beauty of engineering the rest of your life. Okay, so we say that find the ordinary point of the differential equation below. So I believe that you have tried. Isn't it? Tell me in the comment section if you tried, because I want you now to see the flow of the question solution. So don't worry about the style. This is pi over 2, it's a constant, 22 over 7. This is the trigonometrical function, just the cosine function is the PV function. Don't worry, for the purpose, as I told that if we be looking the ordinary and singular points, we don't have problems with these other functions. But if we be solving now the ordinary differential equation by using the power theories, we have problems with other functions, other polynomial functions. So the first step, tell me, so guide me please, first step, what's the first step? First step we say that compare the given ordinary differential equation with what? With second order standard ordinary differential equation, which is what? For this case, we can write also this one, just to have the same coefficient. Okay, second derivative, k in x plus what? Q of x, then we say y in x plus what? P of x, no, Q of r of x, excuse me, r of x y is equal to 0. Right? So if we compare, what do we find? We find P of x is equal to what? Xc minus pi over 2. Right? And then we say that this is Q of x. Q of x is equal to cosine of x. Then we have what? R of x. R of x is equal to what? Sine of x. That is interesting. Right? So if that's the case, we go for the second step. We are going to deal with only the first variable coefficient, which is P of x. As I told you, that you can write this sentence that if P of x is equal to x naught is equal to 0, is not equal to 0, then the point now x is equal to x naught is equal to 0. This original of that differential equation is an ordinary point. So it's an ordinary or is an ordinary point. Is an ordinary point. So then we have to go. So the third state say that let us test what just the condition according to the problem that will be given. Test the condition P of x which will be given is equal to what? P of x, it is x minus pi over 2. Right? Okay. So if the x is so, then we have to substitute P of x is equal to x naught is equal to 0. This is equal to what in positions in the here we have x, so in place with 0 minus what? Pi over 2. So 0 minus pi over 2, this is equal to negative pi over 2. So the next equation, you have to ask yourself, is negative pi over 2 equal to 0? No. So it means that negative pi over 2 is not equal to 0. So if it's not equal to 0, then what we say? Okay? So we say that if this is not equal to 0, then we say that because P of x is equal to x naught of the given problem is not equal to 0, right? Not equal to 0, then we say that then x is equal to 0, or x is equal to x naught is equal to 0 is an ordinary point. Ordinary point. So you can say maybe because of purpose is not equal to 0, then x is equal to x is 0. 0 is what is an ordinary point. Is an ordinary point. So that's the end of solution of that problem. What can you notice before I give you the homework? Because it's the time for me to give you homework. Just refer example 8. P of x, because I want now to give you a technique, so you know how to solve it. I want to give you a general technique. P of x was x squared minus 4. And this one, if you substitute, you find that it's what? Ordinary point. If you refer example 9, P of x was equal to x. And this one was not what? Ordinary point. And then also, if you refer example 10, which we have done it soon, P of x is x minus 5 over 2. And hence you find that it's ordinary point. So you can see now. It means that if the function is involving more than one term, then it's ordinary term. What does it mean? This function is the first term, second term. First term, second term. So it's ordinary term. Once you see that P of x is equal to the function that consisting 2 terms or more than 2 terms, whether 3 terms or 4 terms, it means that you have to know that function, that the ordinary differential equation possesses the ordinary point. If you find that the function is only the ordinary differential equation or the function, at least if you find that P of x of ordinary differential equation involves only a single term, whether x or whether x squared, whether x cubed, whether x power 6, whether x power 7, regardless, you have to know that that point will not be ordinary point. I will teach you further when we'll be discussing about this concept in the next lecture. Stay tuned. So now it's the time for the homework. And this is homework what? 5. Homework 5 or 4? Homework 4. So the question, I guess you have one question, because I know that you need a lot of work. Find ordinary point. It's not a trick one. Ordinary point of the differential equation below. Or for ordinary differential equation below. So what the ordinary differential equation is this one? X plus 2 square. Then this is x minus 1 y dash or y double dash plus what? Plus 3 x minus 1 y first minus 2 okay, x equals 2 x plus 2 y is equal to 0. So make sure that you do, so this will be example 11. So this is homework 4, homework 4 or 04, and this example 2, example 11. So make sure that you do this question and you submit your homework in the comment section so that other students in the world can see that how you solved it successful. And even myself, I will meet you in the comment sections below here. I would like just to remind you, make sure that you subscribe, because we are going to have so many lectures of differential equations, complex variables, very interesting lectures. Make sure to subscribe on our YouTube channel. Make sure also you share these contents with other students. Tell them it's a time for the light of engineering and scientific mathematics to spread into the entire nation of Tanzania and even outside of the borders of Tanzania. So tell them in the comment section, share with them, because something good is still coming. And also, I would like to invite you in the next session, which will be lecture 5, where I'm going to teach you about singular point and reveal the simplest way of finding it. And there's no need for you to revise it several times and cram it. I don't know how to cram. I know how to understand. I've been learning so for almost more than 30 years right now on learning these academic issues. I just began my journey since I was young, almost 5 years ago, 5 years old. So I will be teaching you how to understand mathematics, how to practice it, how to enjoy it, regardless of the distractions that you have got throughout your life. So again, that I would like just to tell you that make sure that if you feel from your heart you want to offer your free willing thanksgiving, you may send so this number, and the confirmation name is Olenjolai&Nekinyi. Or if you want to do the bank transactions that you want to transfer your money from the banking into this online or digital platform, you are not paying me, you cannot pay me. You cannot pay. This is very expensive stuff. I tell you the truth. I know the truth. And that's why that God has captured me since a year ago. You can also send through the bank account to pay for the running costs, the internet I'm using, the editing activities, the electricity. There's a lot of intermediate activities until you deliver this stuff. I tell you the truth. The advertisement for the people to know about what I'm doing, like how you have accepted it, you have received it. So it's a lot of, I don't want even just to mention them because it's kind of making my head pain, because every day I have to think that where I can get the money in order to push this project on. And that money is also my offering to God, to give God all the glory. So you can read the description below to see the bank account and the bank name and all the information of the bank, but also to see my other schools, because I have 6 online schools. This is one of them. So if you want to know other 5 schools for your young brothers, for yourself also, especially for the spiritual, because the kingdoms of heaven come in Tanzania, there's so many schools, but I have included links in the descriptions of this video. So I thank God who have given me this idea, big idea, to help students in my nations of the United Republic of Tanzania. I thank God because He has given me strength, He has prepared me step to step and give me the confidence and give me all the facilities that are required to make these programs to run, at least to move ahead. And I thank God who have given me the opportunity to be a part of these programs. And real God love you so much. I'm always praying for you. Pray for me also, because this is the kind of headache work, because it is actually that I used to teach 40 subjects that 40 teacher has to teach, but I'm alone. But God is faithful, because I'm not alone. I'm with my Father who is in heaven. So I invite you in lecture 5 of the singular point of ordinary differential equation. Don't miss it. Invite your friends. Concentrating, love mathematics, think that we are going to apply these concepts in the real life. That's a challenge that I want to leave for you. Make sure you do the homework before the next session, and may God bless you and meet you in the next lecture. And may God bless you abundantly and be successful in academics and solve real life problems for the rest of your life. Okay? I love you so much. See you then.